In this video, we're going to look at email authentication extension protocols. Firstly, SPF, Sender Policy Framework. The recipient looks at the IP address of the incoming mail envelope and performs a DNS lookup on the domain name to find this as an authorized source. If the lookup doesn't point to an SPF record in DNS which matches the domain which the message sender claims to be sending from, the recipient can quarantine the incoming email. The DNS-TXT record set by the sending organization can specify preferences. So, for example, a soft fail would be where the sending IP address doesn't match the domain in the SPF DNS record, but rather than failing, the sender would want the recipient to accept the email with a warning. This would help organizations transition to use of SPF without causing a lot of email delivery failure initially. DKIM, Domain Keys Identified Mail, uses an entirely different approach, using private keys to encrypt a signature and insert this into the message header. The signature is validated by the recipient, who looks up a public key for the domain. This allows the recipient to block or quarantine those emails where the signature doesn't match the value given by the sender. Finally, DMARC, Domain Message Authentication Reporting and Conformance, uses its own DNS-TXT record to manage alignment between itself and the SPF and DKIM methods. DMARC offers reporting and management capabilities for sending domains and the ability to control which specific senders are authorized, ensuring visibility for attempts at domain fraud. As we have seen, domain-based message authentication, reporting and conformance, DMARC, is a sender email, and again please. As we have seen, domain-based message authentication, reporting and conformance, DMARC, is a sender email authentication extension protocol providing protection against phishing attacks. DMARC aims to improve the identification of spam and provides reporting capabilities for sending domains. It deploys SPF and DKIM and adds alignment based upon a DMARC domain specified in a DNS record. Senders can specify how failure events should be handled according to policy, whereby repeated domains who attempt to masquerade as the targeted domain are specifically disallowed. In Email Gateway Defense, we can configure inbound settings for DMARC. Handling of inbound mail is ultimately determined by the recipient server, but what makes DMARC so useful is its role in providing sender domains with reporting, which in combination with the right tools means that attempts at domain fraud can be tracked. Sender Policy Framework is an extension protocol that allows the receiver to check that an email from a specific domain comes from an IP address authorized by the domain's administrators. The framework refers to the list of authorized sending hosts and IP addresses published in the DNS records for that domain. So receiving email hosts can check the sending IP address in the email against the DNS record. So let's have a closer look at how SPF works. If I have an email client with a configured domain, but the IP address I'm sending from isn't associated with that domain, I should be caught by the DNS lookup. In this example, the postmark server with IP address of 1234 sends a message from joe@bigfishinc.org to jane@kudo.org. On the message envelope, we have a return path email address. The domain in this address forms the basis for what happens next. The receiving mail server supports the SPF function check_host. This extracts and then compares a set of values. Firstly, the IP address of the transmitting email client is extracted. Then the return path on the envelope provides the sender value. Following this, the domain component of this address initially populates the domain variable. But then the domain DNS is checked, and this can lead to recursive lookups. The domain value within this function can therefore be modified by configuring the DNS records. In this example, the kudo.org mail server gets the DNS records of type TXT for bigfishinc.org, looking for the SPF record. The kudel.org mail server compares the 1234 IP address against the bigfishinc.org SPF record. On that basis, the message can be authenticated or not. The version prefix is fairly simple. Since there can be multiple TXT records for a domain, this is the way to let parsers know that this is the record to be used for SPF checking. The following mechanisms are checked left to right. These specify different rules on how SPF is checked for the domain. The record that Postmark gives you has 4 mechanisms: A, MX, include, and all. We can see here that the syntax of the SPF qualifiers allows the sending domain to specify how discrepancies could be handled. We have the domain here for email gateway defense with the German data center. So what would happen if this were not matched with the IP address of the sender? In this case, it would mean a soft fail. So this is the directive to the receiving mail server on what type of failure should occur if none of the prior mechanisms match. The different options for the qualifiers are listed here. Pass an IP address that matches a mechanism with this qualifier will pass SPF. Fail an IP address that matches a mechanism with this qualifier will fail SPF. Soft fail an IP matches a mechanism with this qualifier would soft fail SPF, which means that the host might choose to accept the mail but mark it as an SPF failure. And neutral would be an IP address that matches a mechanism with this qualifier as neither passing or fail SPF. Here is an example workflow for Sender Policy Framework. The elements are as follows. We have the user mail client, the sending server, email gateway defense, the recipient server, the DNS server, and the recipient email. Firstly, the user creates an email. Within the email client, according to configuration, the from field is added. The sending email server processes the user email and passes this through to the outbound EGD delivery system. The IP address on the mail envelope is provided in this case by the email gateway defense, acting as an outgoing mail agent. Does recipient server support SPF? Is an SPF check activated for inbound email? At this point, if SPF isn't activated, the mail is passed by default and proceeds to the recipient. Of course, if a domain has no SPF record, the check is also skipped and the mail goes to the recipient. If SPF checking is enabled, the recipient server performs a reverse DNS lookup of the domain in the return path envelope address to match the sender from IP address on the email envelope. The SPF TXT record can refer to MX and A records in subsequent lookups. The TXT can include additional SPF records, for example for the mail relays and email gateway defense. It also contains the policy to be applied, for example what should be done if the SPF check doesn't provide a match for the sending domain. The DNS lookup returns the results to the receiving server. The IP addresses linked with the sender from domain on the email envelope is compared with the mail envelope IP address. The recipient server applies the policies. The policies can be based on the preferences in the SPF record, or as with email gateway defense, the recipient agent settings may ultimately decide how to proceed. On the basis of the applied logic, the mail is either not delivered, failed, or quarantined, or delivered, soft failed, or passed. This is our second extension protocol for email authentication. The main utility of DKIM is that it protects message integrity. It attaches responsibility to organizations for sent messages. It adds a cryptographic hash as an SMTP header, which itself ensures more reliability and integrity in the delivery of email. Domain Keys Identified Mail, DKIM, allows email to be verified on the basis of a specific domain by affixing a digital signature linked to a domain name to each outgoing message. The outbound mail is signed by an encrypted header value based upon a public key. This ensures that recipients can check the signature and trust the origin of the email. The recipient email systems can verify DKIM by looking up the sender's public key as published in the DNS This also ensures that the email, including attachments, hasn't been modified since the signature has been added. At the core of DKIM's technology is the use of public key cryptography. This means that there is a secret key that only the signer of the message knows, and a public key that everyone knows and that can be used to verify the message. The signer of the email, which can be different from the sender, creates the hash, and the receiver of the email can verify the hash by using the public key, as published in the DNS. Here we have an example of a DKIM DNS record. This record uses the same tag equals value syntax as the email header. The parts of the DNS records are as follows. So we have P, which is being the public key, and K is the key type, or in other words, the type of algorithm. Finally, we move on to DMARC, Domain Message Authentication Reporting and Conformance. This is an extension protocol which is able to analyze and collate details from SPF and DKIM to ensure alignment. Specifically, a domain owner can use DMARC to establish sender email authentication policies. Domain alignment is a concept in DMARC that extends and expands the domain validation intrinsic to SPF and DKIM. DMARC domain alignment matches the messages from domain with information relevant to these other standards. For SPF, this would be matching the domain with that in the return path of the envelope. For DKIM, it would be the domain in the DKIM DNS record. The alignment can be relaxed, matching base domains but allowing different subdomains, or strict, precisely matching the entire domain. This choice is specified in the published DMARC policy of the sending domain. SPF and DKIM checks therefore sit within the DMARC mechanism. Following from this, actions can be defined to determine what should happen to email that fails authentication checks. Actions can be taken, and DMARC offers full reporting capabilities. Over time, it's become obvious that incorporating both DKIM and SPF results are necessary in order to enforce more stringent policies on which emails to allow. This additional check on the alignment offers extra protection. DMARC is supported by Barracuda email protection products, in particular Barracuda Email Gateway Defense and Domain Fraud Protection. It allows the administrative owner of a domain to publish a policy in their DNS records to specify which mechanism, DKIM, SPF, or both, is employed when sending email, how this relates to the from field within the email, and how the receiver should deal with failures. DMARC offers reporting for alignment between DKIM and SPF. So DMARC should be set up by adding and editing DNS records. Web tools can then be used to check both DMARC records and the alignment with SPF and DKIM. Refer to Barracuda Campus documentation for more details on how this alignment can work. A DMARC record is therefore included in an organization's DNS database. This is a specially formatted version of a standard DNS.txt record with a particular name, in this case dmarc.kudo.org. We can see here that the DMARC version is specified. There is a preferred treatment or DMARC policy to be applied. The mailbox to which to send aggregated reports is specified, and the mailbox to which to send forensic reports is specified. Here we can follow the flow of how SPF, DKIM and DMARC all play a role in validating an email. We start with the composition of the email on a pre-configured mail system. In this example, we see that the sending mail server is fully configured to insert an encrypted DKIM header. This email is then passed to the receiving email system, and the receiving mail system's DMARC validation tests begin, based upon alignment around the DMARC published domain in the DNS. Firstly, the verified DKIM domains are retrieved, based on the values in the email header. Secondly, the recipient email system retrieves the IP address from the sender's envelope and runs a DNS lookup to see if SPF regards it as a valid domain for that organization. And then the appropriate DMARC policy is applied, resulting in one of three outcomes. If all is well, the receiver will finally receive the email following standard processing. Otherwise, a failure report is sent back to the sender. And these reports, when aggregated, allow administrators to determine how different domains should be handled. DMARC allows organizations to specify their preferred treatment of mail that fails DMARC validation checks. So we have none, so effectively disregarding DMARC validation and just collecting reporting information. Then quarantine, where we accept mail but place it somewhere other than the recipient's inbox, so typically the spam folder. And then finally by rejecting the message totally, which results in a bounce and a non-delivery report. This is an example of leveraging DMARC, resulting eventually in an email being blocked. SPF, DKIM and DMARC checks are made against a big company's email. Both SPF and DKIM checks pass. However, the DMARC check fails due to misalignment. Jetmail.com are not authenticating, and again please, Jetmail.com are not authenticating against the abigcompany.com SPF record. Since the envelope from IS S1, again please, since the envelope from value is s1.email.jetmail.com, the SPF checks are completed against jetmail.com. However, jetmail.com domain does not belong to abigcompany.com. The DKIM domains are also listed for jetmail.com. This indicates that jetmail.com has configured DKIM for their email systems, but abigcompany.com has not configured DKIM. The domain here, abigcompany.com, is the from address of the email. And so this would be listed in domain fraud protection as a potential domain fraud. It could be allow listed by administrator configuration, but it would require intervention. This is another example of leveraging DMARC. In this case, the email passes the DMARC test. SPF, DKIM and DMARC checks are made against a big company's email. Both SPF and DKIM checks pass. Additionally, the domains align with the DMARC domain abigcompany.com. Thank you for your time.